So good morning or good evening, depending on where you are. Thank you for joining us for our webinar on automated diagram generation of message broker diagrams from Mr. Broker Code. I'll just quickly go through the agenda for the next 25 or 30 minutes. First, I want to start by welcoming everyone, and thank you for giving me your time for this webinar presentation, and hopefully you'll get something out of it. Whether or not you decide to pursue with the product or not, that's up to you, but I hope at least gives you some food for thought. So we'll just jump into to the content. So we'll just spend a few minutes talking about the rationale for what we'll talk about the problem that we're trying to solve. So I'm a message broker developer, amongst other things, and I've worked on lots of different projects. And one of the things of working on a project that pre-existing or a currently operational system is getting over the learning curve and understanding and learning about the system. So how do we know how the system works? How do we understand the processes? How can we better understand the code that exists? And how can we view the code in such a way as to help us both understand it and also find defects in design flaws and improve the overall design. So Message Broker itself has the ability to view a flow. So if we look at a standard the standard Message Broker IDE, we can see that an individual flow has some inputs and some outputs. So we'll pick another flow here. We'll talk about it. So this particular flow here, we see it's a bit of a contrived example, but we'll see from this flow has multiple inputs and multiple outputs, so multiple potential inputs versus multiple potential outputs. So we can understand this flow in the context of itself. So we know it's got dependencies and we know what other things depend on it, but that's all the information we can understand from this particular diagram. So what we're trying to do is build upon what this IDE gives us and finding a way to understand our systems better. Ideally, whatever tool we choose will help us understand the entire application code base, the entire application in as many dimensions as possible. And as I touched on, we want to understand the processes and the relationships and dependencies between the flows, between queues, between files, between different components of the system. And ideally, we'd like to do this in a way that's that one is repeatable and it can be kept up to date, because most of us have probably worked on a project where someone started off with an architectural overview and then the architectural overview got implemented, and then at the end of the day the solution doesn't actually look all that much like the original design diagrams, which means there's very little. There's no way of actually going back and deciding whether or not the design fulfills the architectural requirements, and it's difficult to pass over documentation to other developers if your documentation in no ways relates to the actual existing application. So what we want to do is generate shareable artifacts, diagrams ideally that can be added to our knowledge management tools such as SharePoint or Confluence or Wikipage, and that way not only can we share that with other developers, we can print it out, we can put it up on we can take it to meetings, we can draw on it, we can take it to discussions with the business and use that to explain things to the business. We can hand it to our operational support people and they can understand the process flow, so they won't know that when the particular process goes through a particular set of queues, and they can learn or they can work out better ways of tracking where processes or where tasks have been held up, amongst other reasons or other considerations. And the last one is ties a little bit into how we've actually constructed this. So what we've done is and you may have seen the previous demonstrations, but we've developed the Sonar plugin, and I'll just quickly touch on that. So we've developed a Sonar plugin that automatically analyzes all our codes and gives back a bunch of metrics. For example, the number of nodes, the complexity of OSQL, how much string manipulation complexity there is in a particular SQL function. And then we've developed roughly 72 or 73 particular rules that tell us whether or not it thinks the automatic checking of the code thinks our code is of good quality. Some of the things that this checking actually does lends itself to publishing more information that information that's probably not applicable for Sonar. So, for example, we have a rule, and I'll just try to find it. So, for example, we've got this rule here that says we've got a queue definition which is used in our code, or we've got a queue that's referred to from message flow that wasn't configured in our MQSI configuration file. So our automatic deployment script that's going to create all the queues for us. We've missed a queue. We haven't created it. So the developer can see this particular violation, and they can click on it, and it will tell them some information about the. It can, for example, tell us a little bit about the particular queue. So there's a queue called process, queue, which is not a great queue name, but this particular process, queue name, we can either rename or we can add to our deployment descriptor for our MQSI queue creation. Now, ideally, once the plugin has a chance to identify all these issues, we'd like to have someone to actually publish this information out to a developer. So it's a matter of just simply cutting and pasting. If there's multiple queues, for example, cutting and pasting from somewhere into their IDE and pasting, so that they don't have to manually go and write these queue definitions. Same with other things we developed. We've also got a check to tell you whether or not all the flows exist in all the deployment descriptors. So if you use Ant, you might be using for example, an MQSI create bar, and that bar you might be adding in some message flows. The tool, the Sonar plugin, tracks all the message flows that are being added to the bars via this build script or via a build script, and tells you which ones it's missing. So ideally what we'd like to do is, what is missing is, you do find the missing flows. Ideally we'd like to be able to generate a list with the necessary code, so the developer can just cut and paste that into their Ant task, and then that will fix up that issue, saving them time and effort, and also making it a bit less error prone, for example. Now that's existing checks we're doing. One of the other checks that we've been talking about that we haven't got is things we'd like to do. We'd like to also present back to the DBAs and the developers all the SQL that's actually being generated in the code, or all the SQL that is run by the code. And we'd like to generate it onto some sort of knowledge tool. Sonar itself doesn't lend easily to that sort of sharing of listing of information, but a wiki or Confluence or SharePoint does. So ideally, producing all this extra information, we'd like to have somewhere to put it. And this is how we've come about with our and this is this is the rationale. We'll have the rationale for doing this. This is doing this extension of the plugin. So I'll just stop for a minute just to see if anyone has any questions before we dig into the demo. So just if you have any questions, just quickly put your hand up, or just jump into the chat. Oh, well, we'll keep going with the actual demonstration. So that's the so that was the rationale, and so now we're into the demonstration. So as I said, it runs on the back of Sonar. So what I've got here is a Sonar instance running in the background, and some code. So what I'm going to do is jump into our code. I'm going to run an analysis. Now you can do this via Jenkins or Hudson or TeamCity or one of the other continuous build tools, and ideally you would be, because what you want to do is potentially every time a developer's actually made a whole bunch of changes to the code, it would be good to actually regenerate all the diagrams, all the documentation that the tool actually generates for you, just so that you're always running up to date. And it also means that you can do other things, like you can have a current view of production. So every time production changes, which is probably not as often as anything else, it automatically generates the production view of the artifacts and production diagrams. You might also have a trunk where your current development is, and you'll be generating diagrams for your current trunk development. And then you may have historical documents based on, say, a particular tag or what production may have been like last month, so people can still see it. It just depends on what you want to do with, or how much information you want to make available. So I've just run the analysis and it's just finished. So the analysis, what it's done is it's published a whole bunch of information into Sonar. So it's regenerated all these metrics and all these violations. What it's also done is generated some static content. So if I just look here, and this is just a local web server I'm running. So if you were running, say, Confluence or SharePoint or one of the wikis, you'd be ideally going to be build step in the back of what your build server is doing. You'd be writing, say, all this data to a web dev share, which can be picked up by Confluence or SharePoint, so it's published automatically. Or you might be using a script file to copy it to a Apache directory or a directory in the wiki, so the wikis are automatically updated. But at the moment, I've just got this demonstration running on the back of a web server called Mongoose, so it's just picking up the diagrams from there, from my local version. So I've run my diagrams. It's produced a bunch of files. The main one we're interested in is it's produced a generated page. So the page here is split into a couple of parts. The first one is the diagrams, and which I'll jump into in a second. The second part is the application overview. So what we've done here is, and we touched on it in the rationale, we've tried to give as much information about all the code that we think is meaningful back to the developer or back to the business in a single point. So they don't have to actually go through all the code. So, for example, when it comes to code reviews, yes, you may be going through individual pieces of code. You may be going through different as a single flow, but if you've touched a whole bunch of things, you might want to do it a bit more as a whole process. So you might decide to, for example, go through the lists. So you might want to go through all the queues that are actually in the application and decide whether or not they comply to the queue naming convention. The Sonar plugin that we've written does allow you to add naming rules around this, but this for an existing application where you may not know all the what your naming convention should be, or has been haven't been followed for a while. This gives you an overview of all the queues actually used in the entire application, or at least all the queues used in the application codebase that you've given to the tool to run. That you've got Jenkins or Hudson or TeamCity to check out. So this gives you all the queues and gives you some information about where it's actually used from. This summary here is all the flows. So it's giving us a summary of all the flows and a little bit of commentary, the notes and the short and long descriptions of the flows. So it gives you a bit of a background about, maybe a background of what your flows are doing. So if you want to go find a flow, you might go find fly flow, and it tells you all about it in a single place. Same with queues. You might decide you want to identify, and I'll pick one of the longer queue names because A's, B's, and C's don't really make much sense. So if we go pick up, searches the comments, the flow, the comments, and the queue name. So we'll just pick, for example, called, and you can see that we've got three queues with called in it, and we'll just clear that. And if we go drawing, we can see we've got a whole bunch of flows with drawing in the name of it. So if we want to say we want to call that drawing A, we can see drawing A is used by QA and QB. Drawing A interacts with QA and QB and tells us there. We also have an overall summary of the data sources in the application. So this tells us about our data sources. Gives us a little bit of impact analysis if we want to know where things are being used from or what may need to be tested if particular data source changes. or what happens when which flows are expected to fail if a data source isn't available. We extract information about the properties, the configurable properties from flows, the methods, the Java methods and stored procedures which are used, all the monitoring events defined in the application, and all the file input and output files that are used in the application. So, ideally, what you can do here is if you know the name of the file, you'll jump in here and it will tell you what exactly is interacting with that file without having to go into the IDE and do a text search. So we'll just stop for a second, just check if there's any questions. Right, so it looks like we have a question. So guys, just jump in if you do have a question. So I'll just let okay, so there was a question that's popped up of how is the message flow name defined. That message flow name we're picking up from the message flow file itself. So if we look in the message flow file, there is actually a let me find it. There is actually within the message flow definition in the XML there is a NS. I think we use the NS URI, which is the name that you see within the IDE, just to be consistent. So if you look at what you get in the IDE, which is drawing 1 message flow here, which shows up here is drawing 1. That's the one we pick up from within the message flow or within the subflow. So it analyzes subflows as well. Or files named .subflow. So it just picks it up from the XML of the message flow. So what the tool does, just for a little bit more background on the tool, is it scans the XML and then goes through the XML and pulls out important attributes and elements from the particular nodes, for example. And then, for example, for a I know they have one here, but if I find a compute node, so I'll just go to the compute node for a second. Within the compute node, it's actually here. So within the compute node XML, it goes and finds the relationship to the text, to the textual SQL code, and it trawls through and indexes the SQL code to produce information about code, whether or not code is being referenced, and other things that iterate between flows and SQL. I think there's another question here. So the tool's looking at the existing code. So it's not a code generation tool. So we're not taking a some sort of design artifact and regenerating a message flow. It's purely for analyzing and validating existing applications, and the Sonar component is for checking metrics and validating and measuring quality of existing code. So I hope that covers your question, Fred. So I think your other question is the queue configuration. So we merge the information between the queues defined in the flows, for example, and then we merge that information with the configuration file for queues that you provided, which I'll just find here, in your queue config file. So the queue name that we're picking up is automatically picked up from the message flow code, but the other side of that is the queue names that you've defined as part of your MQFSI configuration. So what that means is by having this as a separate tool on the back of Sonar, you could decide not to manually write any queue definition file. you can just give it a queue definition file, and the tool itself, or the next version of the tool itself, will generate all the configuration elements that you'll need, and then you can just take that and build it. So I hope that answers your question, Fred, but what I might do is just keep it going for the next couple of minutes, and we'll get back to the end and we'll try and answer any particular questions, or we'll organise some one-on-one time, just so everyone can get back to their day. So that there was the architectural overview, or informational overview about the whole application in a number of dimensions, depending on what you're looking at. Now that's one aspect of the diagramming tool, and the diagram component we're talking about is this bit here, which you'll see is about a whole bunch of rectangles and a whole bunch of lines. So the rectangles represent flows, message flows, including subflow component, or the subflow components where they have one or have multiple ones. The lines indicate interactions between those flows depending on the queues involved. So at the moment, the diagramming tool only takes into account queues, so MQ inputs and MQ outputs, but the next subsequent versions will take into account files, SOAP nodes, HTTP nodes, email in and email out. So we'll build all those interactions, and then we'll be providing, as we get more information, we're providing a legend on the top. So a black line will be, for example, a queue interaction, maybe a green line. A green line might be a SOAP interaction, a blue line might be a HTTP interaction, a yellow line might be email, and so on and so forth. So we'll have a legend, might even have some options to turn different layers on and off. But at the moment, we're just talking about queues. So what we're talking about here is what we can see, the information here is we can see that, for example, this particular flow, message flow 1, interacts with drawing message flow 1, interacts with drawing 3, drawing 4, and the logging message flow. So from an operational maintenance point of view, this gives you a good overview of all the different sequences, all the different paths through the code that you might be looking at from looking at problems. And it also gives a new application developer an understanding of how the application ties together. That there is a logical workflow that's happening. And just highlighting, it's hovering over an eye just gives you a chance to actually see it. Where sometimes the lines can be a little bit confusing. Yes. So we'll dig into one. So that's at a high level. So we'll dig into one, and this gives us at the flow component level. So what this is saying, what this is telling us, is that it's given us a bit of description. This is a description that gives us the summary of this particular part of the system. So we can see these interactions with three flows, but going out via 3 queues, Q3, Q4, and log, and there's 2. And this flow is consuming messages from 2 queues, Q1 and Q2. And by this diagram, Q2 isn't actually generated, or there's no part of our system that's generating messages into Q2 in message record close. So Q2 might be an external system, such as a mainframe or whatnot. So this is giving us an extra level of detail and a bit clearer than what this diagram here is giving us. The same information, just a little bit clearer. And if we dig, just a bit of a jump around, so the majority of the drawings are similar. Now this one's an interesting one. And we'll stop on this and talk about this one for a second, because this is what this is telling us, is that we've got an external queue called start, which is triggering this process. As I said, it may be a Java application, it could be something coming from the mainframe, it could be something from Kix or whatnot, or even SAS or some other systems interacting with Message Broker. And it's going through this display calls. That makes sense. Sorry, it's going through this particular message flow here. What this diagram is telling us, or a little bit of extra information and knowledge that the diagram is actually conveying to us, is that Q2 has actually 2 consumers. So a single message from Q2 is going to go out to potentially going to be picked up by 2 different running message flows. So what that means is we don't have deterministic knowledge. We don't have a deterministic understanding of what this queue is doing. Now, because there's a queue, not a topic, and we'll get into a little bit more detail having to do with topics later, but because there's a queue, this would suggest that this may actually be a design issue or an architectural flaw in our code, because we generally wouldn't want the same queue or the same queue being subscribed to or consumed by two different message flows, because there's no way of determining which one's doing the correct logic. Yeah, so this is giving us a little extra bit of knowledge about our system. It's giving us some architectural feedback from the diagram generation tool. Okay, so I'll just stop for see if there's any more questions before I get to the last. Okay, so we've got another question here. So are subflows also printed on this overview? At the moment, subflows are implicitly included in the diagram. So some of these here you can't tell. Some of these here are actually including subflows, which is why they've got multiple queues. So if we go to the IDE, I think, and I don't want to know one off the top of my head, but if we go to the IDE, there's definitely some of these flows that actually are calling other subflows, and the other subflows are calling other subflows, and they're calling queues. And it's contracting all those dependencies, those incoming and outgoing dependencies, into one diagram. What we may look to do in one of our future releases, and if it's something that people would find useful, is to actually have more information about the subflows here. So we actually may have additional diagramming context here to indicate that this flow here has got a number of different subflows as part of their components. And that will give an idea of what those subflows are doing themselves. So yeah, just to answer your question, subflows are included in the information, but there's no way of clearly seeing the demarcation line between what the message flow itself is doing and any subsequent subflows that have been included are doing. So I'll just give everyone another few seconds just to ask any more questions, and we'll get on to the last bit of the presentation, and then we can come back to any outstanding questions, or so we can work out if we can touch base later. So we'll just go through the last couple of minutes, and we'll talk about the. We might just reorder this. We might quickly talk about the things we'd like to do next, and then we'll get on to the technical decisions. So I touched on this earlier. Some of the things we'd like to do. We need to cover more dependencies. So we need to add dependencies for JMS, indicated JMS, triggered event, a file, an email, a SOAP, a HTTP, all those sorts of connections we need to get included. We also need to add support for aliasing of topics and other sorts of more some of the more interesting features that MQ can actually do for you, just so that we, when we have for example, a publish to subscribe, we'd like to have that picked up in a diagram. So rather than having to go through and work out which subscribers there are to a particular topic, we'll actually include that in the diagram as a slightly different icon. So you'll be able to see that you'll be able to see all the different queues that are subscribing to that particular topic. And that way we can traverse the model a lot easier for that as well. We'd also like to be able to handle a distribution list where we're distributing to multiple queues from ESQL. And I touched on it before, place to put automatically generated queue and deployment definitions, and then also we'd like to pull apart, we'd like to extract all the SQL, the entire application, and publish that as well. Now that we'd like to do that for a couple of reasons. One is it's good information for developers to be able to see. It's great information for DBAs to be able to review, because if you just say, oh, I made some code changes, DBAs have no understanding of what the application does. But if they can see the SQL that's actually potentially going to be run by the application, then they can do analysis, and they can do some validation that SQL is going to be performing functionally as efficiently, which you can't do purely at runtime, because you have to catch all the different cases, and you may not get all the edge cases. So there's definitely some things we'd like to do, and there's always going to be more as more people make requests. So if there's a particular piece of information this tool isn't providing for you that you think it would be useful to you, just let us know, and we'll look to see if we can get on the feature back out to be included in the automated generation. So that's going forward, and just a little bit of. We'll just talk a little bit maybe about the technical decisions, just if people are interested, or the technical reasons we did things. So one is whether, and there's the tools that do similar sorts of things, and they're either static analysis tools or they're dynamic or runtime analysis tools. So, and we've decided to go with the static approach for one main reason, that we don't want to be needing to change the running application code to actually be able to generate any diagrams or any information, because that's not doing what that's going to cause more problems. That's what it's going to solve if you have to change the code to monitor it. You don't want to do that, which is, I think, termed the Heisenberg effect. The other thing is, it'd be very difficult to do this if it was a runtime tool to run against production code, because it'd be very unlikely that anyone will give you access to production to be able to run external tools against your third-party tools against you. Or ideally, I wouldn't as a delivery manager, operation manager, allow someone to run a third-party tool against my code in production and affect my real production users and my real business. So this is a tool supposed to improve technology, not possibly cause issues in production when you attach it. The other thing is also you need the complete code to do this sort of dependency and interaction analysis. So from developers' point of view, they may only be dealing with a small subset of the code, the entire code base of the application. They may not have everything checked out. So it'd be difficult for them to run it against their own local execution groups. For example, you could run against their local runtime execution groups, but that wouldn't give you a complete estimate of what the code's doing, because that's only a small subset of code. By having as a static analysis, you can run on the back of, say, Jenkins or Hudson, then you can set that once to run against all the different parts of your code, all the different version repositories of your code. Once that's set up, it will just run automatically, and you can configure it to run via a trigger at a particular time every day, and keep a certain number of historical versions, or you might decide to run it every time someone checks in the code and pull the subversion of a Git repository. So yeah, so that's we're running a little bit over time, but that's the guts of the presentation. I hope everyone got something out of it. If you do have any questions, or would maybe like to set up some time to set up to have a try at setting it up to run against your own code, please feel free to reach out to me. I'm on richard@bettercodingtools.com email, and I believe you would have received an email notification from the webinar itself, so that should track the details as well. Otherwise, if you'd like to replay this presentation, it's actually one of the presentations from the previous that we previously done a few days ago. Is already available under bettercodingtools.com/videos. So yeah, so if you do have any questions, I'll leave the webinar open now, and that way anyone who needs to get on to do something else can get on with their day, or in the case of people who've stayed up a little bit late, can go to bed. Thank you for joining me, and if you have any questions, please don't hesitate to ask them. Okay, so it doesn't look like there's any more questions, so I'll close the webinar now. But as I said, if you do have any come to mind, or you want to organise another demonstration, or you'd like to have a try of running against your own code base and a little bit about a little bit of a helping hand getting Sonar and all the other bits and pieces set up, please let me know. Otherwise, have a good night.